Welcome to day 5 of our 15-day beginner data science sprint. In the previous lesson, we learned how to load a CSV file into pandas and inspect a data frame using functions such as head, tail, info, and describe. That helped us understand what information was available in our dataset. But inspecting data is only the beginning. Once we understand the table, we need to start asking precise questions. For example, which students have low attendance, which students scored above 80, which students studied for more than 3 hours but still scored below 60, and which students improved the most compared with their previous score. So, which students improved the most when compared with their previous score. Today we will learn how to answer questions like these using selection, filtering, sorting, and transformation. Imagine that you are analyzing student performance for a school. The school has hundreds or perhaps thousands of students. The principal asks you, can you show me the student who studied more for more than 3 hours but still scored below 60? Reading every row manually would be extremely inefficient. Instead, we can describe the condition in Python. Pandas will Pandas will check every row and return only the students who satisfy that condition. This is one of the most important ideas in data analysis. We do not simply display the entire table. We ask a specific question and extract the part of the data that helps us answer it. Before we begin coding, remember this distinction. Selection chooses what we want to display. Filtering chooses which rows satisfy a condition. Let me repeat once again. Selection chooses what we want to display. Filtering chooses which row satisfy a condition. We will see this difference clearly throughout today's lesson. Let us begin by importing pandas and loading our student performance dataset. So I need to upload the student performance.csv. It is getting uploaded. So the file has only 10 columns, 10 rows, and it has 5 columns. Now running the code, before running the cell, pause and predict what you expect to see. We should see the first 5 rows of the dataset. So let us run the cell. Okay, it is named wrongly. We need to rename the file. Let us now run it. So we are seeing the 5 rows. The output gives us a quick reminder of the available columns. For today's lesson, we will primarily use columns such as student ID, study hours, attendance percent, previous score, and final score. Your dataset may contain some additional columns as well. Suppose we only want to see the final scores. We can select one column using square brackets. So final score is equal df final score and we display it. Notice that we provided the column name as a string. The result is a panda series. A series is similar to a single labeled column. Let us check its type. The output tells us that final scores is a panda series. The original data frame has not been changed. We have only selected one column from it. Now suppose we want to see the student ID, study hours, attendance, previous score and final score. For multiple columns, we provide a list of column names inside the brackets. So df, then our square bracket, and then the column name inside the square bracket. Then we display. Notice the double brackets. The outer brackets perform the selection. The inner brackets contain the list of column names. We have also added dot copy. We will discuss why dot copy is important later in this lesson. For now, observe that selected is still a data frame because it contains multiple columns. Let us confirm this. So let me rename attendance percent as attendance, or maybe I will rename it here, attendance percent, and then run it. So we can confirm by seeing that pandas.port.frame.dataframe. So selected type of selected is a data frame. The important idea is selecting one column usually returns a series. Selecting multiple columns returns a data frame. Square brackets are convenient for selecting columns, but pandas also provide .log. .log selects data using rows, labels, and column names. Let us select the first 5 rows and display only the student ID and final score. Inside .log, the part before the comma selects the rows. The part after the comma selects the column. Here 0 to 4 selects rows with levels from 0 to 4. One important detail is that .log includes the ending label. Therefore 0 to 4 returns 5 rows. The second part is student ID, final score. Select the two columns we want to display. Pandas also provide ilog. .ilog selects rows and columns using their numerical positions. For example, display df.ilog 0 to 5 and 0 to 3. Before running the cell, predict the output. The rows positions 0 to 5 means that we want the first 5 rows. The column positions 0 to 3 means that we want the first 3 columns. Unlike .log, the ending position in .ilog is not included. Therefore, 0 to 5 means positions 0, 1, 2, 3 and 4. And 0 to 3 means positions 0, 1 and 2. A simple way to remember the difference is .ilog works with labels and names and .ilog works with integer positions. So it does not return the fifth one. I written 0 to 5 here, but the output is it is outputting only the 4 till index 4, not the fifth. Similarly, column indexes 0, 1, 2. In most real analysis tasks, .log is often easier to read because the column names describe what we are selecting. Let us now filter the data. Suppose we want to identify students whose attendance is below 75. We begin by writing a condition. Low attendance mask equals selected attendance less than 75. and then display low attendance mask dot head. Before running this cell, predict what the output will contain. The result is not yet a list of students. It is a sequence of true and false values. Each value corresponds to one row. If the attendance in a row is below 75, pandas return true. Otherwise, it returns false. This type of this sequence of true and false values is called Boolean mask. The attendance percent. This is called as Boolean mask. Pandas can use this mask to select only the rows where the value is true. Let us now apply the mask to the data frame. So low attendance equals selected and then selected and attendance less than 75. It will be attendance percent. So this is our Boolean mask. And then we are using this Boolean mask uh, with this data frame. Now the output contains only the only those students whose attendance is below 75. The condition selected attendance less than 75 is checked separately for every row. Only the rows where the condition is true are included. The output tells us which student meet the condition. However, it does not prove why their attendance is low. The data identifies a pattern. It does not automatically explain the cause of that pattern. That distinction is extremely important in data science. Now let us identify students who may need additional support. We will define an at-risk student as someone who has attendance below 75 and a final score below 60. So here is the code. So its attendance percent is less than 75 and final score is less than 60. Before running the cell, predict what kind of rows you expect to see. Run the cell. The ampersand symbol represents an element-wise AND operation. It means that both conditions must be true. Notice that each condition is surrounded by parentheses. That this is important. These parentheses are important. When combining pandas conditions, place every individual condition inside parentheses. Do not write the Python keyword AND between series conditions. Use ampersand AND for AND. We will use the OR symbol, this symbol for OR. Suppose we want to identify students who either have low attendance below 75 or a final score below 60. So we write this code. The vertical bar represents OR. A row will be included when at least one of the conditions is true. Remember, AND means both conditions must be true, OR means at least one condition must be true. So if I press enter, then I can see it should be attendance percent. See the rows. Either whose attendance is less than 75 or final score is less than 60. One more thing we should remind ourselves that we must write code in Python. So let us try writing the same code as above in the new cell. So our new data frame is need review, the filtered data frame, and that is selected. Then we write the condition, the boolean mask with two conditions. First is selected attendance percent is less than 75, or selected final score less than 60, and then put a dot copy. And then for displaying, we write display. So this writing part is important in Python, else you can't learn Python without writing the code with hands. Let us now answer the questions from the beginning of the lesson. Which students studied for more than 3 hours but still scored below 60? So this is my question. Let me write answer this. So the code for that is this. The question is which student studied for more than 3 hours but still scored below 60. So we'll simply write that. So let us not copy it but write it on our own. So unexpected low scores. These are the low scores by students who studied for more than 3 hours but still scored below 60. So we will be using the selected data frame and then put our condition. So first condition is selected and then study hours is greater than 3, and second condition is selected final score is less than 60, and we need to keep this in parentheses. Finally, we display the unexpected score. Display unexpected low scores. So I think there is no such student in our database. This output may be useful because it shows students whose study time was relatively high, but whose final score was still low. However, we must interpret it carefully. The student who the output does not prove that studying more was low scores. It also does not tell us whether the study hours were accurately reported, whether the study was effective, or whether other factors affected performance. It only tells us that these two conditions appear together in the selected rows. So the rows in our filtered output may not appear in the most useful order. Let us sort the at-risk students by final score. So you can practice writing the code, but for the demo I'm pasting it. So at risk, we have not got anyone at risk. Maybe I will change it to 70. Okay, it was unexpected low scores. I need to change at risk students at maybe less than 70. Okay, so I'm getting two students. And I sort them by final score. So as you can see that they are sorted by final score. By default, Panda sorts values in ascending order. That means the lowest final score appears first. This can be useful when we want to prioritize the students with lowest scores. To sort from highest to lowest, we set ascending equals false. In false, F must be captive. Now the student with the highest final scores appear first. Now we can also sort by more than one column. For example, we can sort by attendance first and final score second. Pandas find first, we need to sort by attendance score. It's not attendance score but attendance percent. Pandas first sorts the rows by attendance percent. When two students have the same attendance, it uses the final score to decide their order. So in our case, we don't have any two students with the same score, with the same attendance. But if they had, then it will then sort them into using their final score. Sometimes the original column names may not be ideal for presentation. We can also rename columns using the rename method. So let's rename student ID with student and final score with score. The dictionary maps the old column names to the new column names. Notice that we created a new data frame called rename. The original selected data frame still has its original column names. Let us confirm this by writing this. So it has original names that selected data frame, but this renamed data frame has the new names. This is useful because pandas operations often return a new object instead of changing the original data frame. Raw data becomes more useful when we create meaningful information from it. Our dataset contains previous score and final score. We can calculate how much each student improved. So let's create a new column. The improvement column did not exist in the original CSV. We created it using the two existing columns. This is called a derived column. If the improvement value is positive, the student's final score is higher than the previous score. If it is 0, the score did not change. If it is negative, the final score is lower than the previous score. Let us sort the students by improvement. The first rows now show the students with the largest improvement. Again, this output tells us what changed. It does not automatically tells us why the improvement changed, why the improvement happened. It does not tell us automatically why the improvement happened. A numerical score is precise, but sometimes categories are easier to communicate. Let us convert final scores into the performance bands. So I think let us write this out. So we will write selected. We want to add a column. So we'll write selected performance band. Band equals pd dot cut, then selected Final score bins equals 0, 50, 70, 85, 100. So this is a way to create performance bands. Then we write labels for each of the bin. And these are first is needs, support, second is developing, third is strong, and fourth is excellent. And we will write include lowest equals true. Now we display this. So we'll display selected and these columns, student ID, final sprint and performance band. I need to write that, not simply press tab. Final score and performance band. And finally dot head, the first 5 rows. The bins defines the score ranges. The labels provide a name for each range. In this example, lower scores are labeled need support. The next range is labeled developing. The next is labeled strong, and the highest range is labeled excellent. These categories can make a report easier to understand. However, the boundaries are decisions made by us. A student with a score of 70 and a student with a score of 71 are very similar numerically, even if they appear in different categories. Categories are useful for communication, but they can hide small differences. Earlier, we created the selected data frame using dot copy, like you can see here. We created it using dot copy. Why did we do this? When we select or filter part of a data frame, pandas may sometimes return a view connected to the original data frame, rather than a completely independent object. If we later try to modify that filtered object, pandas may display a warning such as setting with copy warning. For example, code like this can be confusing. If we write a code like this, it can be confusing. Depending on the operation, pandas may be uncertain about whether we intend to modify the original data frame or only the filtered result. A safer approach is this. So this is a safer approach. Then we can display it and see if we can run the code. Using dot copy clearly does pandas create an independent data frame that I can safely transform. A useful beginner rule is when you plan to modify filtered subset, add dot copy. So this is a useful rule that you can memorize. Pause the video here. Look at the sorted at-risk students. Echo, stop. Look at the sorted at-risk students. Try to explain the most important result in one sentence without using technical words such as data frame, Boolean mask, filtering, or sorting. For example, the students shown here have attendance below 75 and final scores below 60, with the lowest scores appearing first. The purpose of data analysis is not only to write code. You must also be able to explain what the output means in plain language. Now is the time for learner challenge. Now it is your turn. Final students should have who have attendance above 85. And a final score of 80. Then we need to find students who have this attendance above 85 and a final score above 80. Then sort those students from the highest final score to the lowest final score. Display these columns. Pause the video and try to complete the challenge yourself. Before writing the full solution, identify three things. Input, which data frame and columns will you use? Operation, what conditions and sorting operations are required? And expected outputs, what kind of student should appear? And here's the first useful step. So let me write hints for you. These are the three things that you need to identify: input, operation, and expected output. And here is the first useful step. Complete the sorting and column selections yourself. Pause the video now. Let us look at one possible solution. First, we created two conditions. Both conditions had to be true, so we used the ampersand operator. Then we created a copy of the filtered data. After that, we sorted the results using final scores. We used ascending equal to false so that highest score appeared first. Finally, we selected only the columns needed for the output. A one sentence interpretation could be: these students have attendance above 85 and scores above 80, arranged from the highest score to the lowest. Now, and create a new column called needs attention, and its value should be true when either attendance is below 75 or final score is below 60. So the solution will be like this. This derived column can later be used for filtering, reporting, or visualization. The shortcut for selecting same word is Control and D. Today we moved from inspecting a dataset to asking precise questions about it. We learned that selection chooses which rows or columns we want to display. Filtering chooses which rows satisfy a condition. We selected columns using square brackets. We used .log to select data by labels and column names. We used ilog to select data by numerical position. We created Boolean conditions that produce true and false values. We combined conditions using and or. We sorted data with sort values. We renamed columns using rename. We created an improvement column from previous and final scores. We also converted numerical scores into meaningful performance bands using pd.cut. Finally, we learned to use .copy before modifying a filtered subset so that our transformations are clear and safe. The new capability we gained today is the ability to extract exactly the information required for a specific question. The limitation is that a filtered result shows which rows meet our conditions, but it does not automatically explain why the pattern exists. In the next lesson, we will learn how to handle missing values and improve the quality of our data before performing deeper analysis. And here is the complete code. I will be uploading all of this in the GitHub repo and mention that repo link in the comment. So we need to replace attendance by attendance percent. Okay, so we're getting the solution. You can refer this notebook in the GitHub repo that I will be mentioning in the comment section.